OpenAI allows you to upload files that can be used across various endpoints. We used file uploads for vision and file inputs. However, as time goes by, you might want to manage your uploaded files. List them, delete them, or even upload newer versions. You can use the OpenAI dashboard to do this. Here, however, we use the Files API to create a simple file management utility. This is how it will function. Here's a list of uploaded files. Here are the actions available in our program. Let's upload a file. Let's list our uploaded files. Here's the file. Let's delete this file. Here's the file number. The file is gone. Let's code this program. First, we need to declare an array to keep our file list. Let's create our main loop. We define our main loop in the function File Manager. Let's show the user the list of commands our utility can perform. We are now ready to get the user's input. Next, we need to write each of these functions. Let's start with list files. Let's use the Files API. We call the files.list endpoint to get a list of uploaded files. The list of file objects is returned here. Let's see what a file object looks like. ID is the unique ID of each file. Uploading the same file multiple times will always create a new entry giving each one a unique ID. Bytes shows the file size in bytes. Here's the file creation time and Unix timestamp. Files can also have expiration time, after which they are deleted. File name and the purpose can also be found here. Let's loop through the returned file objects and save their IDs in the files array we declared earlier. Here we clear the array first. We're adding each file's unique ID to our array and incrementing our count. Let's extract a few more items from our files object. Here we are getting the file size, converting it to a string, and padding it to a fixed length of 12 characters. Let's get the file creation date and time. Here's the file creation date. We're passing it to a function that takes a Unix timestamp and returns a formatted date and time string, ready to be printed. This function doesn't exist yet. We'll have to write it. Let's assign a number to each file so we can reference them later using that number. We use our count variable for this number. Now we can display our formatted file information along with the file name for each file. We should display the file count after the file listing. Let's add a header for our file listing too. So this function gets a list of uploaded files, displays a header for our file listing, goes through and gets the file information for each file, and displays that information here. And finally, displays a file count. This function should give us the following output. Let's write our creation date function. Our function takes a Unix timestamp and returns a date and time string ready to be printed. We use Python's FromTimestamp method to create a datetime object from our Unix timestamp. Now we can use the string format time method on our date object to get a human-readable string. This string gives us this output. We're done. Let's create our file upload function. We first need to get the file name from the user. Let's read the file and then pass its content to the file's API endpoint that uploads a file. We're setting the file content here and setting the purpose here, currently hard-coded as user data. The call returns a file object. We return the file ID to the calling program. If the file isn't found, we give an error and return none. We're done with our file upload function as well. Let's work on the file info function. This function uses the files.retrieve endpoint to get and display information about a specific file. Let's ask the user to select one of the uploaded files. The file number is the number we displayed next to each file during our file listing. Here we convert the user input into a number. Let's make sure the number is in range. We call this function to make sure it is in range. We will write this function in a minute. If it is not in range, we display an error. We get the file's unique file.id from our files array and call the file's API to retrieve the file information. This will return a file object. We probably should display this information in a nice output. Instead, we just dump the object. We leave it as an exercise for you to pretty print the output. We should probably do a sanity check and make sure we have files in our array before attempting to get its info. We're done. Let's write this function. We simply return true if the number is between 1 and the number of files read in. That's it. Let's write the file erase function. As with file info, let's first make sure we have files. Now we can ask the user about the file to erase. Let's make sure the file selected is in range. Since erase is a non-recoverable action, we ask for confirmation. If the erase is confirmed, we call the files.delete endpoint, passing it the unique ID of the file kept in the files array. We're done with our erase function. Now we can kickstart our application. We go to the end of our file. The function File Manager contains the application's main loop. Calling it starts our application. On application start, and before we go into our main loop, it is a good idea to make an initial API call to get and display a list of existing files. We can make several improvements to our program. We should wrap all our API calls with try-except blocks to gracefully handle errors. As it stands, any API error will cause our application to crash. We should also save more than just the file ID in our files array. Perhaps the entire file object. In that way, for file erase and file info, we can present the file's name for the user's confirmation instead of the file's ID. A much better user experience. Also, for file uploads, we can add more features like optional expiration time and other purposes.